Hi everyone, this video is on exercise 12b question 4. So the point A with coordinates minus 1, 4 lies on the curve with the equation y is equal to x cubed minus 5x. The point B also lies on the curve and has x coordinate minus 1 plus h. So we don't have the y coordinate of point B. In part A, we want to show that the gradient of the line segment AB is given by h squared minus 3h minus 2. Okay. So for this question, basically we just need to use the basic formula of the gradient of a line, which is equal to y2 minus y1 over x2 minus x1. And these are the coordinates of the 2 points that are on the line. And in this case, we have the coordinates of point A. And for point B, we have the x coordinate, but not the y coordinate. So we first need to find the y coordinate of point B. And we just need to substitute minus 1 plus h into the equation for y. So the y coordinate of B is equal to x cubed, which means minus 1 plus h cubed, then minus 5 times minus 1 plus h. Okay, so this is the y coordinate of point B. Now let's substitute everything into the gradient equation and just, work out what the gradient is going to be rather than, expanding now and then going. So I will just do everything all at once. So for the gradient, let's pick 4 as y2. Or actually, yeah, let's pick the y coordinate of B as y2. So we are going to have minus 1 plus h cubed minus 5 times minus 1 plus h. And then this minus y1. So y1 is the y coordinate of A. And for the denominator, the x coordinates of point B is minus 1 plus h. And then this minus the x coordinates of point A, which is just minus 1 is plus 1. Okay, now we just need to basically expand the brackets and then simplify that. So for the numerator, we'll have minus 1 and then plus h cubed. And then from this point onwards, it's going to be a combination of negative and positive terms. I mean, there are two more terms. So one term is minus 3h squared. So that's basically 3 times the first term times the second term squared. And then we also have 3 times the first term squared times the second term. And in that case, it's just going to be positive 3h. And then obviously expanding the second bracket, which is plus 5 minus 5h minus 4 divided by, so minus 1 plus 1 is 0, and then divided by h. Right. So now it's all about, simplifying, because remember that we wanted to show that the gradient is equal to h squared minus 3h minus 2. So let's simplify this. So we have this h cubed term which can't be simplified for now, and same with minus 3h squared. But other than that, we can simplify 3h with minus 5h, which is minus 2h. And we have minus 1, minus 4, plus 5, which is 0. Okay, now we can divide everything by h, and we get h squared minus 3h minus 2, which is exactly what we wanted to show. All right, this is the answer to part A. And then for part B, we want to deduce the gradient of the curve at point A. Okay, so for part B, we are expected to, kind of use the what we have learned in the method of differentiation from first principles. Because when we have differentiation from first principles and we want the limiting behavior, whenever we found the limit, then what we would usually do was then basically see what happens as h tends to 0. So in this case, that's what you're kind of expected to use, even if it's not stated explicitly. So we can just simply say at point A, as h tends to 0, then h squared minus 3h minus 2 tends to minus 2, because h squared and minus 3h just tend to 0, and then we'll only get minus 2 at the end. So yeah, the gradient is equal to minus 2. All right, that's it for this video, and thank you for watching.